Here are the answers for the section 6-6 homework, starting on page 235 oral. We're asked for four different things from the equation. We need axis of symmetry, vertex, is the vertex a maximum or minimum, and then what's the corresponding maximum or minimum value at that vertex. So in each of these questions we're given an equation. The key to doing these problems is to recognize the format of the equation. It has to the second power, so it's a quadratic equation. But it's written in a particular format. It has the letter y alone. After the equal symbol, there is a number that's being multiplied to a quantity that has x in it. It is that quantity that is squared, and then on the very end, there's a constant that is added or subtracted. This fits the general formula y equals a times x minus h squared plus k, where h is a number, k is a number, and a is a number. So we can see in number 1 that the value of a is 2, that the value of h is a 1, that the value of k is a 3. Once we recognize the format and we can find values for a and h and k, we can answer all the questions that we're asked for. The first thing is, what is the equation of the axis of symmetry? If we were to graph this, it would be a parabola, and there would be a vertical line running right down the middle of that parabola that makes the left side look just like the right side. That vertical line is the axis of symmetry. Because it's vertical, it has an equation, x equals, and then some number. In this problem, that is going to be a 1, because it is the value of h. When you want to find the equation of the axis of symmetry, the general formula is x equals h. So it's just a matter of being able to figure out what h is. Now let's get the coordinates of the vertex. The vertex is an ordered pair. It's a point that's on the parabola, right in the center of the parabola. The vertex is on the axis of symmetry, so its x value is 1, and then the y value for our vertex is 3. Now, where did the 1 and the 3 come from? The 1 is the value of h, and the 3 is the value of k. So finding the coordinates of the vertex is a matter of knowing h and k. Question C, is the vertex a maximum or minimum? What this is about is, does the parabola open upwards like this, in which case the vertex is the minimum dot or lowest dot on the graph, or does the parabola open downwards like this, in which case the vertex dot is the highest point or maximum point on the graph? To figure this out, we look at the value of a. In our problem, a is a positive number. So because a is positive, the vertex is a minimum. The vertex will be a minimum whenever a is positive. The vertex will be a maximum whenever a is negative. Then question D, what is the corresponding maximum or minimum value? This is asking for the y value at that particular x value. Remember, we have already figured out what the vertex is in question 1. It is the point 1, 3. When x is 1, y is 3. And so that's the answer to question D. The minimum value of y in this equation is 3. Y will never turn out to be a number less than 3. Now let's run through those same 4 features for problem 3, starting with the equation of the axis of symmetry. To get that, we're going to use x equals h. Well, what is h? That's the 3 halves. So there's our equation for the axis of symmetry. Question B, let's get the vertex. To get the vertex, we're going to make an ordered pair h, k. So that's 3 halves, comma, -6, because the constant on the end is the value of k. Now question C, is the vertex a maximum or minimum? Well, let's look at what a is. A is -4. A is a negative number. So the vertex is a maximum point. Then, what is the maximum value of this function? It is the y value of the vertex, which is -6. Number 5. This almost has the format that we've been using. But we need this to be a minus sign. So let's rewrite this, and in the parentheses, think of x plus 3 as x minus negative 3. Now we know what our h is. It's the negative 3. And our k, it's the 4. And our a, it's the 3. So let's get our 4 features figured out. The equation of the axis of symmetry is x equals h. So x equals negative 3. The vertex is h comma k. So negative 3 comma 4. Is it a max or min? Well, a is positive. So the vertex is a minimum point on the graph. And what is the y value at that minimum point? It is 4. Question 7. We have the same problem with our equation. We don't have the minus sign in there that we need. So let's rewrite this as y equals negative, and then x minus negative 2. Now we can see that the value of h is negative 2, the value of k is negative 1, and the value of a is also negative 1. So our axis of symmetry, x equals h, it's x equals negative 2. Our vertex, h comma k, negative 2 comma negative 1. Is it a min or a max? Well, look at the value of a, it's negative, so this is a maximum. And what is that highest y value at that maximum point? It is negative 1. Now, number 13. 5 comma 7 is a point on the graph of a parabola with axis of symmetry x equals 9. Find another point on the graph. There are different ways to do this, but one thing that might help us is to graph this so we can visualize what's going on. Let's say that this is the y-axis and this is the x-axis. The axis of symmetry is x equals 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The axis of symmetry is a vertical line that crosses through where x equals 9. Now we don't know exactly what the parabola looks like, but we do know that 5 comma 7 is one point on the parabola. Let's locate 5 comma 7. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5 to the right, and then up 7. This dot is on the parabola. The axis of symmetry runs right down the middle of the parabola, so there is a corresponding point on the other side of that axis. Now, what are the coordinates of this dot? The y value is 7 because it's at the same height as the first dot. We just need to find the x value. How far to the right of the axis of symmetry is this dot? Well, how far from the axis of symmetry was this dot? If this is 5 and the axis is over at 9, then it is 4 units between 5 and 9. It's 4 units across here. So what's 4 units to the right of the axis take us to? What's 9 plus 4? That's 13. So if 5 comma 7 is a dot on the parabola, then so is 13 comma 7. For page 235, we're asked to graph these parabolas. These equations are in the format that we're studying in this section, the y equals a times x minus h squared plus k format. That helps us to get the vertex. We know that we graph parabolas by making an xy table, and that one of the rows of our table must include the vertex. So because we know h comma k is the vertex, so we can quickly fill out that middle row. Our vertex is 1 comma 4, because this is the value of h, and that's the value of k. To complete the parabola, choose a number that's to the left of 1, and then a number to the left of that. And choose corresponding numbers to the right of 1, 2, and 3. Now find the y values that go with these x values. Let's substitute in 2. 2 minus 1 is 1. 1 squared is 1. 2 times 1 is 2, and 2 plus 4 is 6. If this turns out to be 6, then so is this. Now let's plug in 3. 3 minus 1 is 2. 2 squared is 4. 2 times 4 is 8. And 8 plus 4 is 12. And if this is 12, then so is this. Let's graph our first parabola. The vertex is 1, 4. Another dot is 0, 6. And 2, 6. And another dot is -1, 12. And 3, 12. Here is this parabola. Now I'm going to switch colors and graph this second equation. Again, by making an XY table. The middle row of our XY table should be the vertex. And we can get that using the H and K values. So our vertex is 1, -4. Then choose two numbers to the left of 1 and two numbers to the right of 1. Substitute them in to get the Y values. Let's plug in 2. 2 minus 1 is 1. 1 squared is 1. 2 times 1 is 2. And 2 minus 4 is -2. So this is -2, and so is this one. Now let's plug in 3. 3 minus 1 makes 2. 2 squared makes 4. 2 times 4 makes 8, and 8 minus 4 makes 4. Now let's graph the dots. 1, -4 is located here. 0, -2 is here, and 2, -2 is here. -1, 4 is located here, and 3, 4 is located here. And we'll graph in the parabola. Notice that the parabolas look very much alike. They seem to be the same width. The rate of change on the branches is identical. The only thing different is where the vertex is located. Now number 3. Again, we have equations that are in the form that allows us to figure out the vertex using values of H and K. So let's make an XY table for that first equation. X plus 1 is the same thing as x minus -1. So the value of H is -1. There is no constant on the end, so the value of K is 0. Our vertex is at -1, 0. Okay, a number to the left of -1 is -2, and left of that is -3. A number to the right of -1 is 0, and then to the right of that is +1. Let's substitute these values in and figure out what y is. First, let's put in 0. 0 plus 1 makes 1. 1 squared makes 1, and in front of that there's a negative, so this makes -1. And then so with this. Now let's fill in 1. 1 plus 1 makes a 2. 2 squared makes a 4, and in front of that there's a negative, so this is -4. And this will also turn out to be -4 if you plug that in. Let's graph that. -1, 0 is here. -2, -1 is here, and 0, -1 is located here, and then -3, -4 is located here, and 1, -4 is located here. Here's that parabola. Now let's switch colors and graph the second parabola. It has the same vertex, -1, 0, as our first one did. The thing that's different is the value of A. So let's fill in -2 and -3 as some additional x values, and 0 and 1 as additional x values. And let's plug in those numbers and see what we get. Starting with 0. 0 plus 1 makes 1, and 1 squared is 1. And when you times by a third, you get a third. And then this will be a third. Now let's plug in 1. 1 plus 1 makes 2. 2 squared makes 4, and then 1/3 times 4 is 4/3. But 4/3 is the same as 1 and 1/3. And this one up here will be 1 and 1/3. Now we can graph it. -1, 0 is this dot. -2, 1/3 is about right there. And 0, 1/3 is there. -3, 1 and 1/3 is about here. And 1 comma 1 and 1/3 is about there. And then we can draw in the branches. This time the parabolas don't have the same width, and one of them opens up and one of them opens down, and that is caused by the value of a. Number 9, find h or k, whichever one we don't know, if this ordered pair solves the equation. So if 6 comma 1 is a solution, then 6 works for x and 1 works for y. Let's substitute those. Notice that the only variable remaining is the letter k, so let's solve this for k. 6 minus 3 is 3. 3 squared is 9, and 2 times 9 is 18. Now we can subtract 18 from both sides, and we get k equals negative 17. Number 11, same idea. Let's fill in 0 for x and that 0 for y. And then solve this equation for k. 0 plus 7 is 7. 7 squared is 49. And negative 1/2 times 49 is negative 49 over 2. Now add 49 over 2 to both sides to get the answer for k. Number 15, same idea. Let's fill in 3 for x and 57 for y. This time our equation has the letter h in it, not the letter k. Let's solve this step by step until we get h alone. First, subtract the 7 from both sides. We have 50 equals 2 times 3 minus h squared. Now divide by the 2. We have 25 equals 3 minus h squared. Now let's take the square root of both sides. When you take the square root of 25, we get positive or negative 5. And that's equal to 3 minus h. Now let's subtract 3 from both sides. We have positive or negative 5, subtract 3 is equal to negative h. If we choose the positive 5, then 5 minus 3 is 2. If we choose the negative 5, then negative 5 minus 3 is negative 8. So h is equal to negative 2, or h is equal to positive 8. For the review assignment, we're on page 231. We had some word problems. We're given some information. Power varies as speed cubed. Let's choose variables to represent power and speed. For power, let's choose P, and for speed, let's choose S. P equals m times s cubed. The second sentence gives us a value of power and a value of speed. Let's make those substitutions. When power is 450 horsepower, the speed of the boat is 6 knots. A knot is a way that you measure speed of boats on water. Let's solve this equation for m. 450 divided by 6 to the third power is 2.08. So our equation that represents power and speed is P equals 2.08 times s cubed. The last sentence says, find the power if the speed is 8 knots. So let's substitute 8 in place of s. Our answer for P is 1064.9 horsepower. Number 9, a square plate 3 inches wide has an inertia of 6.75. What is the inertia for a square plate that's 2 inches wide? And we're told that inertia varies as width raised to the 4th power. So let's choose variables to represent inertia and width. For inertia, I'm going to use I. And for width, I'll choose W. Inertia equals some number times W to the 4th power. Let's use the first sentence to make some substitutions that we can use to figure out m. When I is 6.75, the width is 3. So to find m, we're going to go 6.75 divided by 3 to the 4th power. And for m, we get 0.083 repeating. So our equation that models inertia and width is I equals 0.083 times w to the 4th power. Then we're asked, what is the inertia if the square plate is 2 inches wide? So let's solve for I when we fill in 2 for w. I still have the entire number for m on my calculator screen, so I'm going to leave it on the screen and just press times 2 to the 4th power. And the result is 1.3 repeating. So by rounding it, maybe just 1.33. This problem doesn't give any units of measurement for inertia up here, so I'm going to leave my answer without any units of measurement. On page 229, we're asked to graph some parabolas. Now these are a little easier than the ones we graphed earlier on this homework because they don't have any extra numbers on the end. They only have the x squared term. Because of that, the vertex is 0, 0. So when we make our xy table, our vertex will be 0, 0. And then choose 2 numbers to the left and 2 numbers to the right of that vertex. And let's make substitutions. 1 squared makes 1, and 4 times 1 is 4. And that turns out to be 4. 2 squared is 4, and 4 times 4 is 16. And that turns out to be 16. So we have 0, 0, negative 1, 4, and 1, 4, and then 2, 16, and negative 2, 16. They're up here kind of off the top of my axis. I didn't actually count up 16 marks. So we get a tall, narrow parabola shape. Now for the other equation. Let's make an xy table for that. Again, the vertex is 0, 0, and then negative 2, and then negative 1 and negative 2, and 1 and 2. 1 squared is 1, and 1/4 times 1 is 1/4. 2 squared is 4, and 1/4 times 4 is 1. Let's graph those dots. 1, 1/4 is about here, and a corresponding dot here. And 2, 1 is here, and a corresponding dot here. So this one is a much wider parabola. For number 4, same idea. Let's make xy tables to graph these parabolas. Because there are no extra terms besides the x squared term, the vertex is 0, 0. Here are 2 numbers to the left of 0 and 2 numbers to the right of 0. 1 squared makes 1, and negative 2 times 1 is negative 2. And this is negative 2. 2 squared is 4, and negative 2 times 4 makes negative 8. And this is negative 8. So let's graph this parabola. 0, 0, negative 1, negative 2, and 1, negative 2, and negative 2, negative 8 is here, and positive 2, negative 8 is here. So here's this parabola. And now the other one. The vertex is 0, 0, and then we'll choose numbers to the left and numbers to the right. 1 squared makes 1, and negative 1/2 times 1 is negative 1/2. 2 squared is 4, and negative 1/2 of 4 is negative 2. So 0, 0 is right there. Negative 1, negative 1/2 is here, and a corresponding dot here. And negative 2 is here, and 2, negative 2 is here. And here's this parabola in red. A little wider opening parabola than the one in blue. Next, number 8, we're given an equation, and we're asked if either of these ordered pairs solve the equation. Let's substitute to find out. In place of g, fill in 18. And in place of x, fill in -3. Does the left side equal the right side? -3 squared makes 9, and -2 times 9 is -18, so this one is not a solution. Now let's fill in -18 for g when we fill in +3 for x. 3 squared makes 9, and -2 times 9 is -18. This one is a solution. Number 12, find the value of a if we use this for x and we use this for y. So let's make those substitutions. We get 16 equals 4a, and therefore a equals 4. Number 18, the variable v varies directly as t squared. So we can write v equals m times t squared. Now to figure out m, we have to know a pair of values for v and t. And that's what the next sentence tells us. When v is 45, t is 3. Let's solve this for m. 3 squared makes 9. And when you divide by 9, we get m equals 5. So our equation is v equals 5 times t squared. The next sentence says figure out v when t is 5. So let's substitute 5 where the t is. And we get v equals 125. Number 22, same idea. If h varies directly as d cubed, then what that means is that h is equal to some number times d cubed. Now let's make substitutions. H is -3 when the d is +3. So -3 is equal to 27 times m. Now divide both sides by 27. We get -3 over 27, which reduces to -1/9. So our equation is h equals -1/9 times d cubed. And now it says find h if d is -6. So let's substitute -6 in place of d. Take a calculator and type this in. The result is 24.